Okay, and then for today's last question, right, they are asking that if H, right, is the reflection of G inverse about the x-axis, for which value of x will H of x minus f prime of x equals 0? Okay, so now this is taking us back right to the beginning, right? So remember that this was f of x, okay? And now I've put some things on it, right? But basically f of x was, let's go through it, okay, it was 2x squared minus 4x minus 6, right? And then we determined the equation of G inverse of x, right, to be 1 over 2 to the exponent of x. We said that you can also write this G inverse as just 2 to the negative x, right? When you bring this 2 up to the numerator, it ends up having a negative exponent, right? And then we sketched it, right? So what we sketched was a line y is equals to x, right? And remember that we sketched the graph of g, right? So remember the graph of g was given to us as g of x is equals to log base of a half x, right? And that's the one that I said is sitting on the positive y-axis, right? So that one looked like this, okay? And then from there, we were able to sketch the graph of G inverse, because if the graph of G sits on the positive y-axis, then the graph of G inverse will sit on the positive x-axis, right? Remember, swap x and y around, okay? And it looked like this, okay? This was the graph of G, okay? And we said that this value over here is a value of positive 1, okay? And for, let's just write, this is G inverse, okay? That's the blue graph. Let me zoom in here. Okay, so that's the blue graph, right? And for our black graph, right, that's the graph of G, it would have an x-intercept at 1. Right, so now what they're saying is that they are making a graph H, right, by reflecting the graph of G inverse, so by reflecting this blue graph about the x-axis, right? So we're going to take this blue graph, and the only thing we're going to do is we're going to flip it over the x-axis like that, right? So when we do that, we'll have something like this. Let me find another pen. Okay, so we'll have this. Okay, so this is now the graph of H, right? And the graph of H, because it's just a reflection of the graph of G inverse about the x-axis, it's going to cut the y-axis at the point of -1. Okay, right. So I hope you can see that. Okay, right. Now what they want us to find is to find out when is h of x, right, minus f prime of x, right? They're just playing with notations in this question, right? So for f prime of x, right, we can get that by deriving f of x, right? So f prime of x, right, this is going to be a linear function, right? So we're going to apply the power rule to f of x, right? When we do that, we're basically taking each exponent and multiplying it with the coefficient and then decreasing the exponent by 1, right? Remembering that this constant term has an x term, right, which has an exponent of 0. This one is an exponent of 1. Okay, so then you're going to have 2 times 2, which is 4, times x to your new exponent is going to be 2 minus 1, which is an exponent of 1. Okay, for the next term, you're going to have 1 times minus 4, which is minus 4. And then you're going to decrease this exponent by 1. So 1 minus 1 is 0. Okay, and then obviously the last term will fall away because 0 times negative 6 is 0. Okay, so that's the equation of f prime of x, right? We can sketch this as well on our lovely graph that is full of functions right now. It has a y-intercept at negative 4, okay? And let's just determine the x-intercept of f prime of x, right? So remember that for the x-intercept, you're going to set y equal to 0, right? So let f prime of x equal y. So y is equals to 4x minus 4. And then we set y equal to 0, right? So when we set y equals to 0, we'll have 0 is equals to 4x minus 4. Okay, so notice what we're doing now, right? Setting f prime of x equals to 0, right? That is telling you where this graph of f, right, has a stationary point, yes, but right now we are considering f of x as just the function itself, just this linear function, right? So we are finding where it has an x-intercept, right? Okay. Yeah, okay, let's carry on. Okay, so we're going to move this 4 to the left hand side. Okay, and that equals to 4x, right? So it has an x-intercept at x is equals to 1. This graph has a stationary point at x is equals to 1, right? Well, it's a parabola, so it has a turning point, which I'm sure was correct. If we go back to our sketch, yes. So our graph of f has a turning point at x is equals to 1. Cool. Right. Okay. So now we can sketch f prime of x, right? It has an x-intercept here at 1, right? And it has a y-intercept at 4. Okay, so it looks something like this. I'm going to sketch it in black. I don't have another color here with me. Yeah, okay. Hopefully I don't mess this up. Okay, it's not accurate, but at least I got it to intersect at 1. Right, so then this value here is minus 4. That's the y-intercept. Okay, so what is this question actually saying, right? They're saying when is h of x, right, So when you look at the y values on your graph of h, right, if you take those y values and you subtract the y values on the graph of f prime of x, the output needs to be 0. Okay, we need to find the x value where that happens. Okay, so the graph of h, right, is this. What color did I use here? What color is this? Purple. Yeah, it's this purple graph, right? So if you look at the y values that this purple graph is attaining, right, it's all these negative y values basically, because it's always below the x-axis. Okay, so it never has a y value of 0 because the x-axis is its horizontal asymptote, right? Okay, so it's never going to have a y value of 0, right? The straight line, okay, has y values that are all real numbers. Okay, it can have positive y values or it can have negative y values. Okay, so which means that we now need to concentrate below, right, the x-axis, because that's where the graph of h exists. Okay, right, so if you look at these x values, right, below or less than that x value there at 1, right, so this is an x value of 1. Okay, you can see that the graph of h has its own y value, right, and the difference between that y value and whatever the y value is on the straight line definitely won't be 3, right? But look what happens here at x is equals to 0. Okay, this distance, just shabam shabam, happens to be a distance of 3. Okay, that just came from the sketch. Okay, this question was kind of mean, but anyway. But basically, the x value where that condition is met is an x value of 0. Okay, so if you can think about it in equation form, we're talking about h of 0, okay, minus f prime of 0. Okay, so the equation for h of x is, what is the equation of h of x? Oh, it's a reflection of g inverse. Okay, so it's just the negative form of this, right? So it's negative 2 to the negative x, right? Minus f prime of x was 4x minus 4. Okay, and we need to substitute zeros where we see those x's. So minus 2 to the minus 0 is just 0. Minus 4 times 0 minus 4. Okay, so then we have negative 1, okay, because 2 to the 0 is 1, minus nothing, 4 times 0 is 0, minus 4. Okay, so then do you see my mistake? I'm telling you to be careful about brackets, but I'm not being careful about brackets. Right, so we need to put this in brackets, right? Which means that this is in brackets, which means that this is in brackets. Okay, so the equation for f prime of x was 4x minus 4. Substitute 0 for x, we get 4 times 0. 4 times 0 is 0. Okay, cool. Right, so then input equal signs here. Okay, so then this is minus 1 minus negative 4, which is positive 4 minus 1, which is equals to 3. Okay, so that was also quite a tricky question, but you can see how when you sketch the things out, sometimes just looking at the sketch helps you to solve the question.